Hello, my name is Jennifer Melora Valle, and I am a sophomore studying Earth Systems in the Physics and Earth Science department at Framingham State University. And I am gonna be talking about the study of measuring growth rates of mercenaria from the Turner Farm site on North Haven Island, Maine. One way to study the consequences of climate change is to look at Earth's past. By using geological and biological evidence, we can reconstruct past climate in terrestrial and aquatic environments, allowing us to examine Earth's climate prior to the time of any instrumental or historic record. One technique in paleoclimate reconstruction is sclerochronology, which is the study of physical and chemical variations in hard tissues of invertebrates such as shells of bivalves. Bivalves lay down annual growth lines like tree rings which can be measured. Sclerochronology therefore allows us to obtain a chronicle record of aquatic environmental changes using the periodic growth structures of marine organisms. This study focuses on the Gulf of Maine, which is a large gulf bounded by Nova Scotia to our north and Cape Cod to our south. This coastline can be identified as one of the most productive and important ecosystems, home to many marine species including hardshell clams or mercenaria, which is the species of mollusk that we examine in this study. The two archaeological sites that we obtained the samples from include the Turner Farm site and Nantucket site. As an understudy region, it is important to continue to investigate local trends in the Gulf of Maine to help compare the region to the known global trends. We can capture the global trends in this very productive area. The Turner Farm site is in North Haven, Maine. This site contains four occupational periods which determine the age range of the shells. Turner Farm site also contains the longest and richest surviving record of coastal occupation in the Gulf of Maine. There are also samples from the Nantucket site, which is located off the coast of Massachusetts. In this site, middens date back to the 7th century from the Wampanoag tribe and is also well preserved with minimal human influence. In this image, the Turner Farm site is indicated by the one in the upper part of the Gulf of Maine, and the Nantucket site is indicated by the two located near the Cape Cod. Descending from oldest to youngest, this table shows Turner Farm and Nantucket site date ranges, published in 2001 by Spees and Lewis from radiocarbon dating of charcoal from each horizon or occupation. Shell material used in this study was also sent out for carbon 14 dating in 2016 to compare to these published dates as shown on the right column. All carbon 14 shell dates align with previously published dates. In bivalves, growth band patterns are identified from alternating dark translucent bands and light opaque bands, which happen periodically and seasonally, allowing us to obtain environmental changes such as salinity and temperature. Larger growth bands indicate that environmental conditions were ideal for growth. Hard clam shells, or mercenaria shells, are marine mollusks native to the eastern shores of North America. They're composed of aragonite, specifically acicular aragonite in the periostracum, and calcinite outer layers. Besides the growth rate being related to temperature and salinity, and these shells' calcification rate also decreases with the decreasing aragonite saturation state. Samples in this study date back between 4500 and 400 years BP. In order to obtain the cross sections needed from the bivalves, we use an isomet diamond blade saw. This saw carefully and slowly cuts shells with RO water. Shells were cut from umbo and along the ventral margin so that the chondrophore of the shell is also included in the cross sections for examination. After obtaining the cross-section, they were glued to petrographic slides and were polished for analysis. By polishing the cross-section, it's allowing us to have a clearer depiction of the growth bands. Utilizing the SM4M scope with a 4 times magnification, we were able to take pictures that were later used to measure individual growth bands with the corresponding software of the microscope. On the left image, you can see a picture taken with the microscope after polishing of the cross section, while on the right picture, it shows how we would normally see the shell without any magnification. We determined the growth rate of the shells by using the von Wurtz curve, which is the most frequent curve model used to compare growth. Von Wurtz function takes in consideration height at a certain age, maximum asymptotic shell height, age in years, and growth constant to determine the growth rate. The preliminary data examined 7 total shells that were prepared and measured, 3 coming from the Turner Farm site in Maine and 4 from the Nantucket site in Massachusetts. Mean growth curves were calculated from the mean chondrophore length of the shells. We used the mean growth as comparison from the 2 different sites. This also allowed us to have standard growth index, or SGI, which is the ratio predicted to observed growth. After measuring and calculating average annual growth increments, that information can be used to compare mean growth measured to predicted growth. Shown here, we have mean growth for the Turner Farm site. Closed black circles showing measured growth, open circles showing predicted from the von Wurtz growth functions. The growth curves fit well with the von Wurtz curve. As you can see, the measured growth lines fall below the predicted mean between the first couple of years. After year 12, we can see that the measured growth mean is on par with von Wurtz curve. For the Nantucket site, we can also see that the first couple of years, the measured growth is below the predicted growth. However, in this case, around year 9 was when the measured mean was equal to the predicted mean. Just like the Turner Farm site, the Nantucket site fits along the von Wurtz curve, with mean growth of year being significantly higher than the predicted compared to the other values. The growth index showed on the left graph was calculated by taking the first derivative of the von Wurtz function growth curve for each shell as t approached 0. The calculated results were, for the Turner Farm site, a mean of 1.071 with a standard deviation of 0.285. For the Nantucket site, the mean was calculated to be 0.8388 with a standard deviation of 0.273. The right graph shows the mean phi, which is a quantitative measurement of growth used to compare individual shells of different ages. In the Turner Farm site, we see a mean of 0.804 with a standard deviation of 0.125. In the Nantucket site, the mean was 0.592 with a standard deviation of 0.176. The Standard Growth Index, or SGI, which is the ratio predicted to observed growth, was calculated. The Turner Farm site resulted with a mean SGI of 0.178 with a standard deviation of 0.197. The Nantucket Island site had a mean SGI of 0.225 with a standard deviation of 0.192. In conclusion, the growth rate in the Turner Farm site is slightly greater than the shells from the Nantucket site, indicating that the environmental conditions at the Turner Farm site were more optimal for the mercenaria growth than the Nantucket Island site. These are my acknowledgments. Special shout out to my advisor, Dr. Johnston, who has helped me a lot with this presentation and has taught me basically everything that was presented here. And here it shows all the references that were used for this presentation and this study.